Alright class, let's begin. Today for our video lesson we'll be looking at sections 4.3 and 4.4, but we'll get to 4.4 in just a minute. You do need to know that today's lesson will be over solving equations by adding or subtracting, and we will be looking at similar problems that are found on page 180. Alright, this is the Math 7 video, so in case you didn't realize in the title, make sure you're not watching the wrong video, pre-algebra, okay? So this is Math 7 work. So let's begin. Alright, so here we have two examples of equations. Now an equation is a mathematical sentence that contains an equal sign, which this does right here. Oh dear, my phone went off. I'll fix that. So I won't do that again. There we go. Alright, sorry about that. Let's continue. So here we have x minus 30 is equal to 7. X minus 30 is equal to 7. So what do? Well, in order to solve an equation, we need to remove everything that is on the same side with the variable. And when I say same side, I mean the same side of the equal sign. If you can think of it like this. You could almost look at the equal sign and draw a line like that, okay? So what's on one side, what's on the other? Well, on this side, I have an x and a minus 30. On this side, I have a 7. I want all of my numbers on one side and my variable on the other. That way, I'll know what x is equal to. Now, you can't just go and move this negative or minus 30 over here. You can't say, well, it's a negative 30, I'll just move a negative 30 over here. You can't do that even. What you can do is you can do what's called the inverse operation. If anything wants to cross over to the other side, it has to completely change, okay? It has to just completely be different. So an inverse operation is when you look at an operation like this and you do the opposite operation. What's the opposite of subtracting? It's adding. So we're going to put a plus 30 underneath this. Now, this is an equation. It has an equal sign. If you do something to one side, you have to be fair and do it to the other. It's like if I brought candy to class and I gave it to only half of y'all. That's not fair. I need to give candy to everybody. If I gave 2 pieces to some students, I should give 2 pieces to all the students. If it was for just a free thing, whatever. Now, if it's an award, that would be different. But, so if I give 30 over here, I have to plus 30 over here. Because that's how equations work. Okay? Just trust me on this. That's how it works. So then x, you get x is equal to, well, what's it equal to? X is equal to 37, okay? That's the final answer. You don't have to draw the line there if you don't want to. Some students find it helpful. Others, don't need it. All right, moving on. Inverse operation says I need to get rid of this guy because he's on the same side with the x. So I would put plus 14 to get rid of him. Put plus 14 to get rid of, just because I need to be fair on this side. So I get x. X is now by itself. X is equal to, if I add these together, I would end up with, what, 43? Remember, you can always take this number that x equals, put it back in the place. Remember we did evaluating? Look at that. Doesn't that look like an expression at the top if you were just looking at that x minus 14? And if you were told that x is equal to 43, I could take that 43, replace the x with it, and I would say 43 minus 14. What is 43 minus 14? If you could do the work, pause the video, do the scratch work to the side. If you do that, you'll find the answer is this. If you take this number, replace the variable with it, work it out, you should get what the number on the other side. That shows you that you have the correct answer. So on every equation that we solve, you have a built-in, guaranteed way to know if your answer is right. You can know if your answer is right before the test is graded or the worksheet is graded. You can do the check, okay? All right, moving on. Yep, here we go. Next, we've got, once again, we're going to have to add 4 because we do the opposite. We add 4. So we end up with x is equal to, what's a negative 3 plus a positive 4? Be a positive 1. Oh, so now I need to subtract 20. Is that right? Do I need to get rid of 20? No, I need to get rid of 17. Why? Well, remember, if you draw a line like this, what am I trying to do? If you need, back up the video to that first example and listen to me explain it again. But remember, we're trying to get rid of the number that's on the same side as the variable. 20 is not bothering us. It's this minus 17 that's bothering us. Add 17. We add 17 to the other side, okay? So you should have if you want, drawing the line does help with a lot of students. You should have a plus 17 on both sides, okay? So you would end up with, this would be 37 is equal to x. And I prefer to flip that around. 37 is equal to x is the same as x is equal to 37. You see that? So I prefer to write it like that. If you notice, you've been paying attention, you'll have noticed that so far all of our equations have had subtraction in them, and we've used addition to solve them. Now let's do some 4 examples of the other way, where we start with addition in the problem, but in order to solve them, we're going to have to use subtraction, because subtraction and addition are opposites of each other. They cancel each other out. For instance, if I gave you 5 pieces of candy, and at the very same time I took 5 pieces of candy from you, what have I done? Nothing. I mean, do you have any more candy than you did? No. Do you have any less? No, I have the same. So if I give you 5 pieces and then subtract 5 pieces, it's like adding 0. Okay? That's the goal. We're trying to get basically like a plus 0 on the same side with x. So that gets us x by itself. So we're going to say subtract 7. Subtract 7. Why did I put it there? Well, remember, equals, you got to be fair to both sides. All right, so I end up with just x is equal to 13, okay? Okay, next we're going to subtract. Subtract, so you end up with x is equal to, and you should get what? I think we get 13 again. Oh, wow, 13 and 13. Can we be that unlucky? Okay, next examples. So here we have this example right here. And I think it would be good for us to remember that just because it's written like basically flip-flopped around, you don't get rid of the 45, you're trying to get rid of the 8. So we're going to minus 8. Minus 8. Whatever number you write down here needs to be the same number on both sides, okay? Make sure you're doing that. And I'm going to go ahead and flip it. So I'm going to put my x is equal to, well, what is 45 minus 8? That would be 30, what, 37? I think it's 37. And that's your answer right there. Now over here, I like to make a slight change right here. So I want you to copy this down, but I want you to make this a negative 11. Make this a negative 11, because it's important that we do see some negative numbers, because we will see negative numbers in this section. So here we have our x, and we're going to say x, we're going to subtract 25, because that's the number we need to get rid of. It's on the same side of the equal sign as the x. We subtract 25 over here. 25 minus 25 is 0. That leaves us with just x is equal to, what is negative 11 minus 25? Well, if you need to write it to the side, you could. But you should have remembered that if I've got a negative number and I'm minusing, it's like I put the two numbers together and they make a bigger negative number. It's like saying, hey, The temperature outside is -11. It is cold. And then you say, well, the temperature goes and drops by about 25. The temperature goes down by 25. Okay? So what's the temperature now? We start at -11 and the temperature goes down 25. It's getting cold. It is now -36 degrees. Okay, you got to remember how that works. We're not going to spend a lot of time reviewing over positive and negatives. You got to remember how that stuff works. If you need to, go back and look at your notes over that stuff. Hopefully you've been keeping on to them. All right, let's move on to our last part of our example. We'll move a little bit quicker through this one. This is the multiplying and dividing in order to solve equations. So let's get started. Now, in the last section we just looked at just a second ago, it was adding and subtracting. Adding and subtracting are opposites of each other. So when you do the inverse to kind of reverse it out, that's what you use. If it says add, you subtract. If it says subtract, you add. Okay? You get to be rebellious. Woo-hoo. So multiplying and dividing are the opposites of each other. Think about it. If I multiply something by 2 and then divide it by 2, I'm back where I started. If I multiply something by 5 and then divide it by 5, I'm back where I started. Try that with anything, any number you want, okay? Just try it, okay? On your own time. All right, so what we need to take a look at is that we have 5x is equal to 30. 5x is equal to 30. Sure. What do we do here? Well, we're going to say that I have 5x equal to 30. I've got to get rid of that 5. And this is helpful. I'm going to write it like this because I just find it helpful. I find it helpful to copy it down again a second time. The reason for that is when I go and put my divide symbol, the way I'm going to write it, it might confuse me if I look back at my notes and not remember what the original problem looks like. So we know the original problem looks like this. And now we're going to divide. And I like to do it like this. I just put a divide 5, divide by 5. Okay. So the 5 and 5 are going to cancel out. Swing, swing. You end up with x. And y'all should remember how to simplify this fraction. 30 over 5, what does that simplify to? 6. Good, good, good. Okay? 30 divided by 5 is 6. Don't believe me? Work it out. Okay, you have 7m is equal to -28. We divide by what? Well, we want to get rid of 7, so we're going to divide by 7. Why do we divide by 7? Well, that 7 and that m is telling us that they're multiplying. I want to stop all that multiplying they're doing. So I'm going to stop that multiplying it does by dividing. And that's going to stop it. Bring it right in its tracks. Make it come to a stop, like a train. All right, those cancel out, leave me with just my m is equal to. What is a negative divided by a positive? It's a negative. And that's going to make us a -4. A -4 is the answer to that problem. Okay? Good. Moving on. Let's get done. We're almost done. Almost done with your notes. Almost done with your notes. Okay. Here we have, for our last two examples, this starts off with dividing. Once again, I'm going to write it down here so I can see what the original looks like better. Okay? And then this is divided by 6. When it told me to multiply, I divided. Now it's telling me divide. I wonder what I'm going to do. Well, you're going to multiply both sides by 6. And that's going to get you, because these cancel out. Oh, those cancel out. Remember, if we make our fraction like this and we could cross reduce, that's going to reduce to a 1, that's going to reduce to a 1. So you're left with just x over 1. Oh yeah, I see it. I'd be left with x over 1. Well, x over 1 is just x. Yeah. And 12 times 6 is 72. And there's our answer. Oh, okay. All right, let's copy this back down again. Y, -3 is equal to 7. What do I want to get rid of? The -3. So what do you multiply by? Negative 3. Okay. Why do those cancel out? Well, you just put it over 1. Negative 3 and negative 3 can go both into each other one time. That would cancel to a positive 1. That would cancel to a positive 1. You're left with just y by its lonesome. Does it equal 7? No, because you got to do the same thing. Whatever you do here, you do over there. So you multiply by negative 3, you multiply by negative 3. 7 times negative 3. Positive times a negative. What's that equal? It equals negative. It equals negative 21. That's what it equals. And we done. Whoop, whoop, we done. All right. Now, go back over these notes. Write down your questions because we'll be going to get into this stuff come class time. Exciting. Okay, bye.